Hello, my name is Manohar Rao. I will now demonstrate how Android applications can be easily, effectively, and quickly developed in a collaborative, model and test-driven environment comprising Rational Team Concert and Rational Rhapsody. This demonstration involves three collaborating team members, Deb and Marco, the developers, and Bob, the product manager. The application being developed is a simple stopwatch for the Android phone. Significant parts of the application have already been developed using Rational Team Concert and Rhapsody. Bob has now added a new change request and assigned the relevant tasks to Deb and Marco to implement. The screen you're seeing is the Eclipse-based rich client of Rational Team Concert, or RTC for short. We're looking at Deb, the developer's RTC client. Deb is logged into the Jazz team server, which is the collaboration repository enabling Deb to assign and receive work items to and from other team members, share and manage project assets such as models and source code files, and view reports showing the current state of the project. Deb's RTC client is currently displaying the work items perspective. Within this perspective, we see here on the left-hand side Deb's inbox, in which has arrived a new work item. Let's take a look at the new work item that Bob has assigned to Deb for the change request. This work item is about implementing a new lap timer control. It has been assigned to Deb, it has a medium priority, and it's been planned for the current iteration, Sprint 3. Deb will now accept this work item and will start working on it. To carry out her task, Deb will use the Rhapsody plugin. Here I have switched to the Rhapsody modeling perspective. Let's now focus on Deb's task at hand. Here at the bottom you see in RTC's source control pending changes view that Marco has finished his task, which is that of implementing the lap timer display, and has delivered his work related to that task. Before Deb starts with her work for this task, she needs to accept the changes made by Marco for the lap timer button. Before she accepts the changes, she can check to see what changes Marco has made by looking at the differences between his change set and her existing model. Let's see how this can be done. On one of the artifacts that he has changed, we can open the compare editor, which will in turn invoke the Rhapsody diff merge tool. The Rhapsody diff merge tool is a graphical differencing tool. Here we can see each one of the differences. Let me start at the first difference. We can take a look at the differences. And here we see that the differences are in a class diagram. On the left hand side is Marco's class diagram, and on the right hand side is Deb's class diagram. And here we can see the difference very clearly in the blue color. Marco's version of the class diagram has a new class, as we would expect since he was implementing the lap button. So let's assume that all the other changes are okay and Deb is satisfied with the changes. Now what she can do is accept these changes so that she's now up to date with the latest copy of the model in the team stream. Let's now take a quick look at the model in its current state. Here you see a UML use case diagram. We can now see here the main use cases for the stopwatch application. Just as importantly, you can also see here that the traceability to requirements is also modeled. The requirement can be created in the model or imported from requirements management tools such as Doors, or even from Excel spreadsheets or Word documents. The model provides a visual and effective means for capturing traceability from requirements to analysis and design artifacts to source code. To enable the modeling of Android applications, the Android SDK is provided as a model library in Rhapsody. Here you see all the key elements of the Android SDK organized into packages. Let's take a look at the app package. You can see the activity class from the SDK available for modeling. This enables you to graphically define classes in your application and relate them to the classes in the SDK. Let's switch to our main activity class diagram. In this class diagram, the main activity class for the stopwatch application is modeled. If I now drag and drop the activity class from the Android SDK, You see that Rhapsody automatically visualizes how the SDK is being used. In this case, the stopwatch main activity class is derived from the Android SDK's activity class. Let's take a look at the core design of the stopwatch application as shown in this class diagram. Note that this design is completely target independent. This means that this application's design can be used on many different targets, such as Windows or Android or BlackBerry, etc. Here is the main class for our stopwatch design, which is the stopwatch timer class. Let's take a look at the behavioral model for the stopwatch timer class. Here in this UML state chart, Deb has modeled the logic of the stopwatch timer class. The state chart models the complete dynamic behavior of the class by capturing its states, the transitions between them, the events that cause the transitions, and the actions that should be performed by the class in response. Rhapsody provides significant time savings by generating source code for state charts as well as test workbenches for testing them. In the interest of time, here is the completed state chart for the stopwatch timer class that Deb has finished. Now that the implementation is done, let's generate code for the model. To begin with, let's test this on the host machine before we deploy it onto the target. Rhapsody makes this very easy by providing for build and execution components that can be created for each target platform. Here, in the first instance, I am generating code for the host platform, which in my case is Windows. Here we can see that the code was generated. Now I can take a look at the code from within elements within the diagrams as well. Here we see that the code for that particular state, and indeed the entire state machine, is in this stopwatch timer.java file, and here we can see the specific code for entering the lap state. A key feature of Rhapsody, called dynamic model code associativity, enables the user to work either in the code or the model. Rhapsody will keep the model and code in sync dynamically. This enables the user to work within the most appropriate editor for a given task. Let us build the application for this test configuration. We see that there are no errors, so let us run the application we just built. So I will run the application as a Java application. You can see that the Rhapsody debug perspective has been invoked. We can now test our application by using model level debugging. This involves animation of key diagrams, such as the sequence diagram you see here, and state charts. You can also debug the source code in conjunction with the model by running the Eclipse or ADT debugger. Let us start this execution by clicking on the Go button in the Animation Manager. Here we see that the sequence diagram is automatically recording all the events and interactions occurring between the various objects in our application as we perform actions in the application. We can also see how the state chart is being animated. The current state is highlighted in both orthogonal regions. We can simulate the injection of events by using the event generation capability of Rhapsody. This is a key part of the test workbench that enables early and frequent testing of application components. Let's generate the start-stop event. You can see that the start-stop event has taken our state machine into the started state and is indeed calculating the time and displaying the time. Deb is now satisfied that the application is working on the host. She'll now repeat this process for the target by using the Android emulator. Retargeting in Rhapsody is very simple. We just make the Android component active This component has already been set up to use the appropriate classes from the design. As before, We will now generate code for the Android target. And we will build the configuration. And as there are no errors, we will now execute this application. This time we will be running this as an Android application, since this is targeted to the Android platform. Here we have the graphical user interface of our stopwatch application running within the Android emulator. Note that you still have the option, even though it's not shown here, of using Rhapsody's code instrumentation capability even for the target, thereby making the model debugging capabilities available while running the application on the target. This is not only true for the Android emulator as target, but also for an actual Android device connected to the host machine. As you execute the application on the device, you're able to watch animated sequence and state diagrams as we did with the host testing earlier. Let's use the graphical user interface here to test out our Android application. We'll start with the start to stop button. We can see that time is being displayed. We can test the reset button. You see that time is reset. We can test the new feature, which is the lap button. So we can click on the lap button, and then when we click back on the lap button, you see that the time is continuing where it left off. And we can say now that Deb has completed her implementation of the lap timer control and is ready to deliver her changes back into the stream. To do that, back in the pending changes view, she will check in and deliver. She can put in a comment for the change set. And she will have to associate the change set with a work item. In this case, the work item that was assigned to her by Bob for this change request, implement lap timer control. So now Deb has successfully implemented the change request. Deb will now mark the work item as completed. Let's now switch to Bob's view of the project. RTC is not only available as an Eclipse client, but it's also available as a web client. Bob is using his internet browser to log into the Jazz server to view the stopwatch project. Here you see the project dashboard showing viewlets for aspects such as the team velocity, burn down, current work items or stories, open work items or stories by priority, etc. He can look at the current sprint plan, look at the planned items within that, and here he has the ability to see the developer's task board. In the developer's task board, he can see each one of the team members' work items. For example, here we have Deb and Marco's work items listed by category, such as the ones that need to be done, the ones that are in progress, the ones that have been done. In our particular instance, we can see that the implement lap timer control work item that was marked as complete by Deb is now in the done column. To give you a better idea of RTC's project management features, here is the Jazz.net website with the project dashboard for the actual RTC development project. This dashboard is showing the current state of the RTC development project. For example, it shows where the latest milestone of the upcoming release of RTC is, what the open defects are for this release, what are the open tasks, etc. You can view this on your own by visiting the website jazz.net. In summary, this demonstration showed how RTC and Rhapsody can enable a collaborative, model and test-driven approach to the development of reusable software for Android applications. Thank you for watching.